simple example I started with didn't do a calculation and return a value. It just printed something on the screen. But lambdas can return values if you want to. They can do calculations. Very often your lambda is a single line long, and if that single line is a return statement, then the compiler can figure out the return type, and you do not need to specify it. More usually, there's more than one statement in the lambda, and therefore you will specify the return type. I'm going to show you the syntax for it. You probably won't like it. I'm not 100% sure that I like it, but there's really no better approach to how to specify the return type of the lambda. People sometimes want to put the type before the square brackets. Of course, type name and then square brackets already has a meaning in C++ when you're declaring arrays, so that won't work. So here we're saying, hi, I'm a lambda, that's the empty square brackets. I take an integer n, I return a double, open brace, body of my code, which includes multiple return statements, end brace. Sometimes when I show people this syntax on a slide like this, they say, wow, that's really unintuitive. You know, that arrow is already there for calling a member function when I have a pointer to an object. Now I'm so confused. You know, we overload operators all the time in C++, and we're fine with it. You know, star sometimes means multiply and sometimes means dereference a pointer. When you see this in context with other code around it, you actually are going to find it pretty readable. Here is a lambda that returns something. It doesn't need to say that it returns something. It can just be deduced. So I have another vector, we'll call it v2, and I'm using an algorithm called transform. It goes through one vector and does something to another collection. So in this case, it goes from the beginning to the end of V and repeatedly calls back inserter on V2. Back inserter inserts items at the back of a collection. There is a front inserter for some collections, and this is simply a way to transform one collection into another. So here we're going to transform V into V2 by using this lambda. This lambda returns the value n that's at that element of the vector cubed. Because the lambda just has the one return statement, the compiler can figure out that it returns an integer. It knows the type of n times n times n, and so I don't need to specify it. We then just carry on with the same things you've seen before to print out the contents of V2. I'm already running, so let's just run down to here. And you can see we're printing out 0 cubed, 1 cubed, 2 cubed, 3 cubed, and so on, up to 9 cubed. That's easy enough. I didn't have to specify the return type. What if I do have to specify the return type? Here I have a vector of doubles, and so I'm going to be inserting, again with back inserter, into that vector. I obviously need to insert doubles now rather than integers, and the body of the lambda, which runs from here to here, there's quite a lot of braces, so let's be clear about this. The body of the lambda checks to see if n is even. If it is, I'm going to cube it. Otherwise, I'm going to divide it by 2.0. So 1 will become a half. Because I have two different return statements, and other as well, the if and all of that, I have to be clear and say this lambda returns a double. I think that's actually quite readable in that context. Let's just let it run. I'm just going to print them out in what's hopefully becoming a familiar approach. You can see that the odd numbers have been halved and the even numbers have been cubed as we go through from 0 to 9. You've seen quite a few lambdas working. And you know, I kind of cheated when I asked and answered, what's a lambda? Because although I told you what it was, a way to represent an operation or some functionality in an object, I didn't really explain how it's done. You see, the compiler generates for you something called an anonymous function object. A function object is an object that has certain capabilities, normally you would write these by hand. So you would, for example, override the round bracket operator. That's the function call operator, to actually perform a particular operation or calculation when people call the lambda or call the function object. The compiler generates this override for you. If you say that your lambda takes round brackets, int n round brackets, then the operator round bracket that is written for you by the compiler, its parameters are int n, or whatever other parameters it was that you said the lambda took. When you use that arrow syntax to say that you return an int or you return a double or whatever it is that you return, the compiler generates that to be the return type of the override of the round bracket operator. But there's more to it than that. The anonymous function object that's generated for you by the compiler has member variables. And these member variables hold all of the values that are used inside the body of the lambda. Now, so far, the bodies of the lambdas I've shown you haven't used anything other than the parameter, n in most cases, that it was passed. But the lambda has access to information from the calling scope, and that information is put into member variables of this anonymous function object that's being generated for you. Now, an anonymous function object is an instance of a class, and it has member variables that hold values, and you can keep that instance in a variable, as well as what we've been doing, which is just passing that variable immediately to a function, such as the standard for each, that turns around and uses it. So in order to fully get all of how you use lambdas, you have to understand how to control those member variables, how to set up what the member variables of the lambda will be, and you can even do things like changing them from their default, which is const, to something that can be changed within the body of the lambda.